everyone. Good morning. So, did you know that according to the World Bank, 55% of the population in Africa were employed in the agriculture sector? And did you also know that out of that number, 80% of them were smallholder farmers? And they produce 90% of the food produced on the continent. Interesting statistics, right? Yet still, a chunk of the agricultural studies and reports always indicates the numerous challenges that are being faced by smallholder farmers. This study therefore takes a different narrative by providing solutions to the problems that are being faced by smallholder farmers, including limited access to finance. And as such, most financial service institutions feel reluctant to provide finance to smallholder farmers. And so this research actually seeks to, 1, to reduce the loan decision and processing time, 2, to provide an objective process in arriving at loan decisions, 3, to improve chances of loans recovery by financial service institution, and 4, to achieve wider agricultural financial access coverage. With the rapid development of machine learning and artificial intelligence in applications in different areas, this study therefore looks at the applications of 3 machine learning algorithms, which included the logistic regression, support vector machine, and decision tree. Since this is a classical classification problem and following rigorous data cleaning, data pre-processing, and feature engineering, and having to create new features from some of the already features we had so we could include to the model to make it more reliable, I would want to take a minute to just share some of my insights with some of the visualizations that were done. How do I go back? How do I get back? I want to get back. Okay, so I want to, next slide. So I want to share some of the visualizations that I did. This is the feature for the soil type. And this, since it's a classification problem, we had 2 classes, with 1 to indicate a bad client and then 0 to indicate a good client. So this shows the counts for each of the categories for the soil type. So looking at each of the labels for the soil type for the bad credit and good credit, we do realize that the soil type could be a good feature to be included in the model. My reason being that looking at each of the counts for each of the labels in the category of the soil bad and then good credit, you realize that you can see some distinct differences, which means that this actually could be a good feature to include for the classification. It could actually help in our classification, and as such, the feature was actually included in our study as well. This actually shows the results from the 3 machine learning algorithms that were developed, the logistic, support vector, and decision tree. And it shows the accuracy for each and then the confusion matrix for each. From this, the decision tree actually was chosen as the better alternative. For future research, we are looking at adapting this model to other crops, as this was done just on sorghum. We're looking at adapting it to different crops as well. And secondly, we're looking at collecting more data from the farmers to be included, more features to be included in our model as well. My name is Deborah Kanubala, and Asante Sane for your attention. And this work was done in collaboration with Manobi, a digital orchestration company based in Senegal, Dakar. Thank you very much for your attention.